Okay, Bismillahirrahmanirrahim. We'll continue doing this section 9.6. Where what did we do? We did the root test, the ratio test, and also we did the root test. Yeah. Now the next thing in this section is strategies for testing series. We have studied various tests just to check convergence or divergence of an infinite series. There's some guidelines. Yeah, there is nothing. يعني you can take it 100%. There's just some guidelines or things to look at. If the n term does not approach 0, then the series diverges. Don't forget the special types of series: geometric, p-series, telescoping, alternating. Don't forget the test: integral test, root, ratio, and comparison test. Okay. Sometimes more than one test is applicable. Okay. Now we'll try to see the most efficient one. Okay. If we look at these cases, these are just different problems. Let me try to think about different methods. Yeah. The first one, what you will do. You notice that the limit of this is not 0. Yeah. So an is n plus 1 over 3 n plus 1. So it will be the limit of an as n goes to infinity. Same degree, that will be 1 over 3 not equal to 0. So right away, that means this series diverges by n-term test for divergence. Okay. So it means all the tests which we have, we are concerned, we are dealing with the limit as equal to 0. The limit of an not equal to 0, right away, this is divergence. So we are concerned only about the limit an equals 0. If you think about this, this will remind us about what? Yeah, it's a geometric series, r to the power n. So b, which is this one. So I have geometric series with r pi over 6. Pi is 3 point something over 6, so this is less than 1. So converges. Okay. C. An e minus n square. What shall come to my mind? Yeah. It's integral test. Yeah, because I can't find the integral of this. But this is u, this is du somehow. Yeah. So I need the integral test for this problem, where I know that an is positive and continuous. And the check is decreasing, so check f of n equal to n. So I need to check this function, f of x, where f prime will be what? Will be e minus the square times what? Times derivative of x, which is 1, so plus x times minus 2x, e minus x squared. So I can take e minus x squared common factor, 1 minus 2x squared, which is negative for x greater than or equal to 1. Yeah, this is always positive. This is negative. So it means f is decreasing. So now everything is ready for the integral test. So check now, starting from 1. So check the integral 1 to infinity of x is minus x squared dx. I need 2.5. That will be half limit t goes to infinity 1 to infinity. Yeah, you know what? I can find the integral right away. It's e to the power minus u, but this is du. So it's minus is minus u, which is minus x squared. Yeah, differentiate this, you get that one. So very clear. So from 1 to infinity, that will be half. Let me do it right away. 1 to t. Let me do it in steps. Okay. That will be half times what? Limit t goes to infinity minus is minus t squared plus is minus 1. Well, t goes to that will be half times 1 over a converges. So that means this series converge. Okay. This one, what shall come to my mind? Yeah, if you have function over function, then you can think of conversion test or limit conversion test. Yeah, limit conversion test make it easier. 1 over 3n plus 1. So limit conversion test with bn 1 over n. So I have limit n goes to infinity an over bn. That will be limit n goes to infinity 1 over 3n plus 1 times n over 1, which is 1 over 3 positive. I didn't know this divergent harmonic series, then that means this series, I know that diverges, so that this series diverges. Okay. Next one, if you see minus 1 to the power n, one of the things should come to your mind that it is alternating series, 3 over 4n plus 1. A n 3 over 4 n plus 1. Yeah. Or think about the alternating series test. I notice if we take bn, then for sure the limit equal to 0 and bn plus 1 less than or equal bn. Actually less than. Yeah, because the denominator will be bigger. Okay. So the series converges by the alternating series test. Very clear. This one, factorial and powers. So what shall come to my mind? What shall come to my mind? What are the tests I need to think of? Ratio test, very clear. Yeah. Yes. Yeah, what will come to my mind? Just the ratio test. So I have an is n factorial over 10 to the power n. So I need to check L limit n goes to infinity an plus 1 over an. That will be limit n goes to infinity. N plus 1 factorial over 10 to the power n plus 1 times n to the power n over n factorial. That will be limit n goes to infinity. That will be n plus 1 over 10, and this limit equal infinity. So this series diverges. That was which part? F. G an is n plus 1 over 2n plus 1 all to the power n. Is it? Yeah. Very clear. I need the root test here. Here I have the ratio test. So I have the limit, the nth root of this. That will be my L. Then goes to infinity. That will be the limit. The nth root will kill this. That will be limit n plus 1, which is very clear, half less than 1. So this series just converted absolutely, actually. Okay, so just a quick review about what we did about the convergence. We have this is the series. The first one was the main one. I need the sequence of partial sums. Sequence of partial sums, sequence, partial sums. We call it Sn. If that sequence converge and the limit equal to S, then we say this series is converge and its sum equal to S. Its sum is equal to S. Diverge, then it will diverge. That's the main definition. Then we have these tests where we have the n-term test, just to review, n-term test, yes, we know it, and check the limit not equal to 0. All the other tests are concerned only with the limit is equal to 0. Because the limit not equal to 0, limit of n not equal to 0, right away, the test, it means the series diverge. But that will not give you anything about the convergence, nothing about the convergence. Geometric series, geometric and telescoping, these are the two series where you can find the sum, where you can find the sum. Okay. This is the geometric R to the power n, and this is telescoping, but they will cancel each other. Also, we have the P series, 1 over n to the power p. It will converge if p greater than 1 and diverge if p between 0 and 1. By the way, the geometric will converge if absolute value of r less than 1 and diverge absolute value of r greater than or equal to 1. And this is telescoping. It will converge if we do the cancellation, this, the limit of the term, then it goes to a value, then it will converge, otherwise it will diverge. Alternating series, where n is positive. This is the alternate, this is the form that I need to check limit is equal to 0 and it's decreasing, then right away it means it will converge. And they also have the remainder for remainder theorem for that, remainder estimation. Integral test, if it's continuous, positive, and decreasing, then I check the integral. If the integral converges, then it will converge. If the integral diverges, then it will diverge. The root test, I need to check this, less than 1 or greater than 1. Be careful if there's 1. Test is inclusive, and the same thing for the ratio. Direct comparison. If the bigger converges first, or the smaller will be converged. If the bigger, if the diverges, then the bigger will diverge first. And the limit will fix all of this. We'll just make it all over L. Well, check L is positive, then right, then either both will converge or both will diverge. These are also, we have this test, if the limit is equal to 0, if you notice this limit conversion test, it gave you only if L is positive and finite. However, there is a case if it is 0 and the limit of the denominator converges, then the limit of the numerator converges. If it is infinity and the limit of the denominator diverges, then the limit of the numerator diverges. If the limit is equal to infinity and the series in the denominator diverges, then the series in the numerator diverges, and the same thing if the limit equals 0 and the series in the denominator converges, then the series in the numerator diverges, converges. Yeah, I have this in the alternating series estimation, and these are some definitions. Absolutely convergent if you take the absolute value of the n term, then it's converge. Conditionally convergent if it is convergent but not absolutely convergent. Yeah, if it is absolutely convergent, then for sure the original series converge. These are some hints how to think. Yeah. Which test you need to think if you have a special format. If the series of this form, 1 over n to the power b, then I need to think about what? The b series. If it is this form, this is geometric series. Okay. Yeah, sometimes you need to manipulate it algebraically. If it is similar to the p series or geometric series, then you need to think about the comparison test. Yeah, or the limit comparison test. A rational function or algebraic function of n involving roots of polynomial, then the series should be compared with a p series. If you have a rational function, polynomial over polynomial, yeah. Okay. The comparison test applied only to series with positive terms. Yeah. If we have, but you can apply it if taking the absolute value, and this it will converge, then it means the original series converges. If the limit not equal to 0, yeah, this is means divergence, if you can find it quickly. If it is in this form, -1 to the power minus n to the power n minus 1, then you need to think about the alternating series test. Factorials or product, something to the power n, usually I need to think about the ratio test. Yeah. Yeah, but if the limit goes to 1, then it will give you nothing. If it is in this format, then I need to think about the root test. If n equal f of n, then I need to think about the integral test where I can find the integration. Yeah, in this problem, what I will do, just I want to check which method shall we do? Just the method. I'm not working on the details. This is very clear. Let's think about what the limit is half. So this is n term test for divergence. What this one? This one, it will be limit comparison test where I'll take it with this series into the power 3 over 2 over n cubed, which is 1 over n to the power 3 over 2. So I'll do limit comparison test. This is, we did it before, this is integral test. I think this one will be alternating series test. Yeah. This one, I need to think about what? Ratio test. This one, comparison test. With what? Where I'll take bn 1/3 to the power n. We'll do the comparison test. Yeah. Now let me do some old exams questions quickly related to this section. Yeah, 2 to the power n minus 1 times 3 to the power n plus 1 over n to the power n. If you notice this series, let me rewrite it. That will be summation equal 1 to infinity. 2 to the power n, 2 to the power minus 1 times 3 to the power n times 3 over n to the power n. So my an is what? 3 over 2 times 6 to the power n over n to the power n. Yeah. So if we do L using the root test, that will be limit. Yeah, let me do it here. L will be limit and goes to infinity. The nth root, everything is positive. No need to bother. That will be limit and goes to infinity of what? The nth root of 3 over 2. Okay. Times 6 over n. Yeah. That limit and goes to infinity. 3 over 2 to the power 1 over n, which give you 0 times 6 over n. And that give you what? This is 3 over 2 to the power 0, which is 1. That would be 0. This done 1. So the series converges. Actually converges absolutely. Okay. Which one is true about this series? Actually, we did it before. Yeah. I think we did it before. Minus 2n. Yeah, which is this one, which is diverges. Yeah, sometimes the questions will come like this. You give you the series, and we'll ask you some questions about it. So this is very clear divergent, done before. This one, how to think about it? I would think about the ratio test for sure. Yeah. So I need an will be this. What will be L limit an plus 1? And the absolute value will kill the minus sign, so it's no need to be about it. That will be, you know what, let me write it here. Just to give it more space. So you have n plus 1 to the power 100 times 100 to the power n plus 1 over n plus 1 factorial. Reciprocal of this. N to the power 100 times 100 to the power n. Yeah. Now we need to manipulate the algebraic things, algebra. Yeah, this cancelled with this. This cancelled with this, give you here n plus 1. I have 100 to the power, yeah, that will be limit and goes to infinity of what? This with this give you 100. Over n plus 1 times n plus 1 over n all to the power 100. Now apply the limit, you will have what? Yeah. This is goes to infinity. So you have 100. This will be what? 1 to the power 100. So if 100 over infinity, that will be 0. Less than 1, so it will converge absolutely. This one, 1 minus 3 over n. Yeah, with the ratio test. What? Did I did on? Let me take L. This is my AN. Yeah. So L will be the limit as n goes to infinity of the nth root, which is this, all to the power half, 1 over n, I mean. That will be limit n goes to infinity, 1 minus 3 over n, all to the power n. And that is what? If you apply the limits, which we discussed before, yeah. So it will be e to the power x. Yeah, we know what this is. This is e to the power minus 3, which is 1 over e cubed, which is less than 1. So it's convergent by the ratio, by the root test. This one, very clear, I need the ratio test. So it will be L, will be limit, n goes to infinity, an plus 1. Everything is positive, so need to be better. That will be limit, n goes to infinity. What is that? This is 2n plus 2 factorial over 3, 5, 7. This is 2 times n plus 1. So it's 2n plus 3 until 2n plus 1, then 2n plus 3 times the reciprocal of this over 2n factorial. This is cancelled with this. So what you have the limit and goes to infinity. This is you need to open two things, two terms. So I have 2n plus 2, 2n plus 1. This is times 2n factorial over 2n plus 3 times 2n factorial, cancelled. So I have second degree, that will be, yeah, it will goes to infinity. So it will be divergent by the ratio test. Since degree 2 over degree 1, okay. For the series converges to what? I will do the root test to get what? Limit as n goes to infinity of the nth root. This, that will be limit. Well, this limit is a over b. So he wants the series to be convergence. Convergence, this is less than 1. So a less than b. That will be my answer. Yeah, this is very clear. I need the ratio test. But it's a little bit. Forget about minus 1 to the power n. That will be 2n plus 1. N plus 1 factorial over 7, 12, 17 times. This is n plus 1, so I have 5n plus 7 times the reciprocal of this over 2 to the power n factorial. So that will be what? Limit and goes to infinity of what? This one cancelled with this one. And they have 2 times n plus 1 over 5n plus 7. Yeah. From 2n plus 1, 2 to the power n plus 1 and 2 to the power n, I'm getting 2. N plus 1 factorial and n factorial, I'm getting n plus 1. Yeah. So the answer is 2 over 5 less than 1. So it will converge. Yeah. By applying the ratio test, what will happen? Let us see. Well, alpha is positive. Okay. You want to check the ratio test, what will happen? So I need L, which is the limit n goes to infinity, an plus 1 over an. That will be limit n goes to infinity of what? Yeah, I have n plus 1 factorial over alpha plus 1, alpha plus 2, until I reach what? Alpha plus n plus 1 minus 1, so alpha plus n, the spherical of this. Over n factorial. So that gives me what? Limit n goes to infinity. Yeah, all of this cancels with this one. And I have what? N plus 1 over alpha plus n. That is 1. So it means the test fails. Okay. I have powers here, powers. So for sure, the root test will come to my mind. So I need to do an 3 times 2 to the power 2n over 3 to the power n times 3 times n to the power n. Okay, so it will be the nth root. Everything is positive. So what's the nth root of this? Yeah, let me do it step by step. This is the nth root of 3. This is 2 to the power 2n to the power 1 over n. So times 4. This one is 3 times the nth root of 3. Well, actually, this 3 with this 3 cancelled. Let it be better. So I have 4 over 3. And here I have n. Yeah, so it's very clear that the nth root, that will give me 4. And this one give me 3. And this one give me n. So it will be L limit as n goes to infinity with the nth root of this, which is clearly 0 less than 1, so it will be converged by the wrong test. Yeah. Now he said if you apply the ratio test, so let us apply the ratio test. What will happen? L will be limit n goes to infinity, an plus 1 over an. Absolute value, everything is positive, so I need to be better with the absolute value. That will be square root 1 plus n plus 1 over 1 plus n plus 1 all square. First circle of that, 1 plus n square over square root 1 plus n. So this limit will be limit n goes to infinity. Yeah, square root n plus 2 over square root n plus 1 times limit. This will be what? 1 plus 2n plus n square over 1 plus n square plus, it's n plus 2, so that will be 4n plus 4. Yeah, very clear this will equal to 1, this limit. Also, this limit is equal to 1. So the answer is 1. Why this limit is equal to 1? Yeah, just divide by, or yeah, this limit, square root n plus 2. If you take square root of n as a common factor, that will be 1 plus 2 over n under the square root. Yeah, cancel, so I have 1. So that this is inclusive. This is fair. Okay. Yeah. Let me check this one. What is an? It is minus 1 to the power n factorial cubed over 3n plus 1 factorial. Okay. So I need to check L, which is the limit, and goes. So very clear. I need the ratio test. Yeah, -1 with the absolute value will be ignored. So I have n plus 1 factorial cubed over 3n. Yeah, I put n plus 1, so 3n plus 3 plus 1 factorial. That will be limit n goes to infinity of what? N plus 1 factorial, n plus 1 factorial, n plus 1 factorial over. Oh, yeah, sorry. Times the reciprocal of this over n factorial cubed. Okay, so this will be the limit of what? You have n plus 1 factorial over 3n plus 4, which is 3n plus 1 factorial times the rest. This times 3n plus 1 factorial. Yeah, that will be the limit as n goes to infinity. Each one cancelled, give you n plus 1. And this cancelled with this. The remaining is so the answer, I have the same degree cube in the numerator and the denominator, so I have 1 over 27, which is less than 1. It will be absolutely convergent. This one. Yeah. I'll do the ratio test. I have L limit n goes to infinity. Yeah, the absolute value will kill the minus, so that will be limit n goes to infinity of what? N plus 1, n plus 2 over 3 to the power n plus 1. Reciprocal of that. That give you what? That give you, yeah, that give me what? Limit n goes to infinity of n plus 2 over n times 1 over 3. And this limit is 1, so it will be 1 over 3 less than 1. So it will be converges absolutely. Yeah. Let me do this one, then I will stop. 3 to the power n over 4n. Yeah, I can manipulate this a little bit. That will be what? Minus 1 to the power n, 3 to the power n over what? This is 2 all to the power n. So it's 2 to the power 2n plus 2 to the power n, which I can simplify to what? I can take 2 to the power n common factor. I have 2 to the power n plus 1. Yeah. I think that will make it easier. So this is summation minus 1 to the power n, 3 over 2 to the power n over 2 to the power n minus 1. Okay. So let me do the ratio test. See what will happen. Yeah. We have the ratio test. L will be equal limit n goes to infinity. Yeah, -1 will be killed with the absolute value, so no need to be bothered. So I have 3/2 to the power n plus 1 over 2 to the power n plus 1 minus 1 times the reciprocal of this over 3/2 to the power n. Yeah. I did not put the absolute value class. The absolute value will kill the -1. So no need. The rest are positive values. Okay. Now this one will be what? Will be limit n goes to infinity. 3/2 times this one. This is 2 times 2 to the power n minus 1. So for this one, I'll divide everything by 2 to the power n. That would be limit n goes to infinity, 3/2. Divide by 2 to the power n everything. Every term. Yeah. This one as the limit goes to 0. This goes to 0. So I have what? 3/2 times 1/2. That will be 3/4 less than 1. So the series absolutely converges. Yeah. Okay. So I think I will stop. I can do another video with the rest. And let me stop the recording. Thank you.